All right, ladies and gentlemen, I want to take this opportunity to do two things. First, I wanted to go through that rule that we kind of brushed over at the end of class yesterday, just to give you the opportunity to see it. And then that way, if you do know this rule and you recognize it, you can use it. I just think, there's a lot to remember already with everything. So to add another rule like this just seems like a lot. So I'm going to still introduce it. I'm going to take this opportunity to do a second thing, which is show you again how to do this process for factoring using the box and diamond, as I call it, rectangle and X, whatever you want to call it, that method that we use for factoring that will work for anything. And so those of you who are still trying to get used to it can see that again. All right, so here we go. The rule is very similar to the one we did before. It's a little harder to identify. It's called a perfect square trinomial. Okay, so now if you remember from these examples, these are pretty easy to identify. Oops, two terms, both of them are squared, are perfect squares. And as long as you identify that, you can set it up as the first term, x and x, for example, here, and then 3 times 3 is 9. One has to be positive, one has to be negative. To make this a minus, okay, and to eliminate the middle term. Those are pretty easy to identify. And I don't think anybody would have too much of a problem seeing that, identifying it, and writing it to where you don't have to use the box and the diamond, okay, like here. And you guys did a really good job when we took a look at that. All right, now this is a similar type of thing, but I think it's a little bit harder to identify. It's called a perfect square trinomial. And what happens is you'd have to look at, so for example, here's one right here. It's kind of acting funny. What you notice is the first and last terms are perfect squares. So the first thing you have to notice is that first and last terms are perfect squares. Okay, x squared would just be x, 9 would be 3. And you can see right here, they do explain, they write that out right here, x squared and 3 squared. Okay, and look at the middle. The 6 is made up of a couple things, and this is right here is the formula. The middle is 2 times the x, the square root of that, and the square root of 9 is 3. I don't know what's going on with my mouse here, guys. Sorry. All right, that's supposed to be a parentheses with a 3. So 2 times x times 3, as in 6x. If you can identify the first two are perfect squares and the middle one is made up of those squares and a 2, a 2 and then those squares, what you can do is you can bet you're going to have two sets of parentheses, x times x, 3 and 3, and then check that 6 is positive, right? Oh, wow, those 3s are, oh, good. Well, you can see the scribble's real nice, but you can't see the 3s. Let's have to kind of slow down a little bit here. And then check this. This is a plus. These would both be plus. In fact, we can write it as x plus 3, 3 squared. You can see that they have that written right there. Okay? Same thing with if it's a minus in front of the 6. Wow, Screencastify updated, and it is not working pretty. Let's see if I can change this. Still kind of janky, but all right. Same thing. Even if it's a minus, that just changes the minus in front of the 6. That just changes this to a minus. So again, you see x and 9, they're both perfect squares. So as long as the middle is made up of 2, this square, which is x, and this square, which is 3. 3 times 2 is 6. You got the x. So what we can do is 2 sets of x. This is a minus 3. Again, this is why I kind of skipped over this. This is a little bit harder to identify. You're really going to have to pay attention to, are these perfect squares on both ends? Let me show you an example. Okay, so this looks like any other thing that we would factor. And that's why I said it's probably just best for us to remember 3 things. One is if there's a 1 out in front, we could just do this. And then we're thinking what numbers multiply to 16 but add to 8. If there's a 1 out in front, then we just do it. We can do it this way. That's funny that that happened exactly when I said that. Multiply to 16 and add to 8. So 16 would be 1 times 16, 2 times 8, 4 and 4. 4 and 4 add to 8. That's one way we could do this problem. Okay. Another way we could do it is obviously the box and the diamond, which I'll show you down here with this one. But just to kind of say, we could do it this way. Works for all of them. Okay, so I say we remember this, and then the difference of squares, we remember. All right, but if somehow you can remember a 4th rule, which I don't even remember this sometimes, but it's n is squared, 16 is a square. In the middle, you have 2n times 4 because of the square. So then you could set this up as it's all plus n plus 4 squared. That's up to you, okay? That is up to you if you want to try and use that rule. It's allowed. If you notice that both the first and last term are squareds, you can just set it up. And there's 3 terms. You can set it up as n plus 4. And there's 2 sets of them. Okay? Same thing here. If you happen to notice, these are squares. In the middle, you can see is 2 times 2x times 3. It's the number 2 is always there. Couldn't tell you why. Actually, I could. I don't think that's necessary. Okay, and you set it up. There's going to be 2 sets of 2x, 3, and this is minus, so minus. Okay, so if you happen to notice that, great. Please use it. If you notice that both the first and last term are squares, I just think these aren't special looking enough to be like noticeable. You know what I mean? When we have a difference of squares, it looks like this. It looks like x squared minus 9. There's only 2 terms. They're both squares, so you set it up as the squares for x, 3 times 3 is 9, 1 plus, 1 minus. I just think that's easy to identify. This stuff, it's a little harder to identify. This looks like every factoring problem we've ever done. And again, you can do it that way. Let me show you the classic ways just to review, okay? Because I don't think you need to memorize this rule. It's 1n squared. That's a horrible one, but because there's a 1, we don't have to do the box and the diamond. You can. So if you remember that, do it. But since there's a 1 there, we know this has to be n times n. That makes up n squared. So we can just focus on numbers that multiply to 16 but add to 8. Okay? So it ends up being 4 and 4. 4 times 4 is 16. 4 plus 4 is 8. You're done. Okay? Great. Again, you could use the box and diamond, and that's exactly what I'm going to do here. Okay? I'm going to go ahead and do that. So, and the reason we would do that is there's a number out in front, and that changes things. Okay? We can't just say n times n is n squared. We have that 4 that we, have to deal with, and it complicates things. And so let's go and do this process one more time so you guys can see it. All right? It's the same every time. I'm hoping you're catching on. It can be used for everything. Even this one up here where I kind of did the shortcut. If you don't remember the shortcuts, always come back to this, okay? First and last term are going right in. We need to split up that negative 12x in the middle but everything else, you're good, okay? The negative 12x, like I said, is what we're splitting. Whatever we pick has to add to negative 12. All right? We need to narrow that down. There's a lot of things that add to negative 12. So diagonal. 9 times 4 is 36. And I just got that by multiplying the diagonals. Okay? Because the diagonals that we're going to pick also have to multiply to 36. So that's why that works. Okay? So two numbers that multiply to positive 36 and add to a negative, they both have to be negative. Trying to think here. 1 times 36, that's not going to work. 2 times 18, that's not going to work. 3 times 12, 4 times 9, 6 times 6. Hey, there we go. Starting to wonder there for a second. So both of them have to be negative. That will result in a positive, but when we add them, we get negative 12. So there you go. Negative 6x and negative 6x. All right. So let me erase that just to unclutter that. So the purpose of this diamond or x is literally just to figure out how are we going to split up negative 12x. Okay. The multiplication gives us some guidance on that because we could pick anything. We have to narrow it down. And once you're there, you're just going to do the factoring. So start with 4n squared. I'm seeing that when I look up, I see a 6, and when I look across, it's a 6. So 4 and 1 as my numbers here aren't going to work, so it's got to be 2 and 2. All right. Minus 3 here. All right. Negative 3 times 2 is negative 6. Same thing here. And that makes sense. This is from our special rules, so they're going to be the exact same thing. And so even if you don't notice it, though, you have a way to do it, all right? And guess what? You also now have a video of this process, the box and diamond. So if you ever need to come back to it, come back, open this up, watch the process, take a look at it, follow along, go from there, all right? Ladies and gentlemen, take care. Have a fantastic rest of your day. Complete the assignment in today's folder. Make sure you show your work, take pictures of your work, and I'll talk to you guys on Friday. All right, take care.